Let's begin with the slide, flip, and turn page of your homework. So once again, we agreed that a slide was a translation represented with a capital T. A flip would be a reflection represented with a lowercase r. And a turn would be a rotation represented with a capital R. So I'm just going to do 3 of these. We did the first 10 in class. So let's look at number 11. Which transformation would move triangle 13 onto triangle 1? Well, you could see that to move triangle 13 onto 1 would be a rotation, which we're going to represent with the capital R. Triangle 4 to 6 would be a translation, represented by a capital T. And triangle 11 onto 12 would be a reflection. So conveniently, we got one of each in number 11, 12, and 13. Now, once you have the notation down, the letter, we need to add the subscript. So in number 11, to move triangle 13 onto triangle 1, that would be a rotation around the origin. And it's going to put 13 onto 1, you're either going to have to move it 270 degrees, or you can go backwards, which we'll represent with a negative 90 degrees. This one has 2 possibilities. You can also rotate it around the origin 270. Because remember, the natural rotation will be counterclockwise, the order of the quadrants. Number 12, to move 4 onto 6. I know some people saw that as a rotation, but it's not. Just to illustrate that, I'm going to highlight triangle 4 and show you that all you need to do to get 4 onto 6 is drag it. If you just can slide it right on top of 6, that's the definition of a translation. However, we need to know how it is moving. Since we're on a coordinate grid here, you need to find 2 corresponding points. What I mean by a corresponding point is that on triangle 4, if we moved triangle 4 directly on top of triangle 6, this point that I'm highlighting black would end up right on top of that point in triangle 6. So the question is, how can we get that point to be directly on top of the other point? Well, I like to think of the change of my x first. Well, I'm going to move that point 1, 2, 3 to the right, and then it's going to go 1, 2, 3, 4, 5 down. Well, the move to the right is a positive move of 3, and the move down is a negative move of 1, 2, 3, 4, 5, 6. So we would write that on number 12 as a T3, comma, negative 6. 3 to the right, down 6. Finally, number 13 would be 11 onto 12. You should be able to visualize the line of reflection here. This one's not so challenging. It's right there. But we do need to know how to write the equation of that line. Well, it's a vertical line, so I know it's going to start as an x equals. And we're just going to start at 0, 0 here and count where that intersects our x-axis. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. So it's x is equal to negative 6. So hopefully you could finish the rest. Let's look at another page from your homework. Let's look at the transformations as functions page. I'm going to jump to the second page here because this is really where we need to be. A point gets input into a transformation machine, and then we take that very output and put it into another transformation, and we have our ultimate answer. When we have more than one transformation acting on our point, we call this a composition. So this is where the compositions begin. These are compositions. And just to show you how this would actually look in one of our exams coming up, or our view sheets coming up, is that we take the point that we're putting through a composition and we put it on here on the right side. So I can say point A, for example. I'm going to put it in parentheses. And when we write compositions, we write them from right to left. So since the first thing that's acting upon point A is a reflection over the y-axis, I would move from right to left, and I'd say point A is going to be reflected over the y-axis. But then if we're going to take that point after it's been reflected over the y-axis and do something else to it, we're going to put a little circle here. That means we have a composition. We have more than one action happening to this point. And then we're going to, as you can see, it's a translation. It's a translation where we're going to be adding 4 to our x and subtracting 2. So this is really what it's going to look like for you. I'm going to box this up. This right here is what a composition looks like. Well, we can do this in the machine up here and see how it goes. Well, to reflect something over the y-axis, I'm just going to put the formula right up here. Well, when we reflect over the y-axis, the y stays the same and we change the x, right? So if we're going to change the x, that x is going to become a positive 3, and the 4 is going to stay the same. And now we're going to take that new point, that's what makes it a composition, 3, 4, and put it into the next machine, and we're going to add 4 to the 3, which is 7. And we're going to subtract 2 from our 4, which is 2. And that's our ultimate answer. All right, let's look at number 10. And number 10, I'm going to do more the way that I would do an actual composition. Okay? So I'm going to rewrite this. Well, actually, number 10 is a backwards composition. So this would be a slightly more complicated. So let's actually just do this one through the machine here. Well, one thing that is easy about a rotation of 180 degrees is that whether you're going forwards or backwards, it's the same exact formula, because if you rotate 180 and another 180, you're back where you began. So the formula for a rotation of 180 is the same as a reflection to the origin, which is negative x, negative y. So to move that backwards, it's just like going forward. So if we take r double prime and we put it through a rotation of 180, or even if we go backwards, it's the same thing. It's going to become a positive 4 and a negative 8. We're just going to switch the signs. Now, when you're doing a translation backwards, I'm going to take each part of the formula here, the x minus 1 and the x plus 1, and I'm individually going to set them equal to their respective letters, coordinates, and the point. So I'm going to say my x minus 1 was equal to 4, and my y plus 1 was equal to negative 8. Well, now I'm just going to solve for x. Well, x is going to be equal to 4 plus 1. X is equal to 5, so I have my value of 5. And y is equal to negative 8 minus 1, and y is going to be equal to negative 9. Okay, now this one I'm going to do. This huge, monstrous composition, this 4-part composition I'm going to do as a composition, number 11. Okay, so here we go. We're going to start with point M, and M, when I write this in composition form, I'm going to put M here on the right side because we work from right to left in compositions. And the first transformation is going to be a dilation with a scale factor of 1/2. So dilations are capital D, subscript, scale factor. And after that happens, I'm going to have my composition mark, it's going to be reflected over the line y equals x. Well, and after we reflect that over the line y equals x, something else is going to happen to it. We have another part here. It's going to be translated. It's going to be translated in a -4, 3. T -4, 3. And finally, the last part of this composition is going to be a rotation around the origin of 270 degrees. Now, when I have a composition that looks like this, right? It means we have a point, and I'm going to write the coordinates next to it, and it's 610. So our coordinate is 610, right? There's our M. And we're going to be put it through this machine. Now, for the sake of maintaining our right to left system here, I'm going to, underneath each one of these, open up a new set of parentheses, because our point needs to keep on changing relative to the transformation above. And underneath, I'm just going to put the formula for each one. Well, I know that when I am dilating, I'm going to take the scale factor, which is k, and multiply it by my x, and the scale factor, and multiply it with my y. Well, that's pretty simple. So I just need to multiply both of my numbers here by 1/2. Well, 6 times 1/2 is 3, and 10 times 1/2 is 5. Well, then I'm going to move over here, and we have a reflection over the line y equals x. Well, that's a simple formula to remember as well. That's switch them. Take the numbers and just put them in the other number's place. So the 5 is going to go to the front, and the 3 is going to go to the back. And now I'm going to do a translation. A translation here is just going to look like x minus 4 and y plus 3. All right, that's easy enough. I'm going to take my 5 and subtract 4 and get 1, and my 3 plus 3, and that's going to give me 6. And then finally, the formula for a rotation of 270 is y comma negative x. That means my y value for the previous point is going to go to the front and not change, and my 1 is going to go to the back and become the opposite sign. And this is our answer. Okay, let's take a look finally at some of the questions from the composition sheet. The compositions of transformations. So I'm just going to take a couple of these, just to give you a couple of these that are a little bit trickier. Let's take a look at number 3. It says rectangle MULE, graph it, right? I'm going to graph it right here. So 1, 2, 1, 5, 8, 5, and 8, 2. And let's see, this was my M, this was the U, this is the L, and this was my E. And it says it's a rectangle, so I'm going to connect M, U, L, E. And there we go. So we did the given. It said graph rectangle MULE. Now graph and label the following composition. So really what they're asking us to do here, if I were to add something to this picture, they're really saying, well, take M, U, L, E, and put it through that composition, each of the points through that composition, which means I'm going to work over here. So we're going to have 4 different problems. I'm going to get rid of this part of the question for a moment, just to give me some space here. So I'm going to magically make that disappear. Okay, so we're going to put 4 points. So I'm going to, right underneath here, I'm just going to put their formula so we could see them, right? It's good to have it, or I'll put them up on top here. How about that? Well, the formula for a reflection over the y-axis, all right, I'll put it here, the reflection over the y is keep the y, change your x. And the formula for the reflection over y is equal to x is just switch them, right? Put the y in the front and put the x in the back. All right, so we're going to do this with a couple different points. So let's start with my M. So the M here is 1, 2. So I'm going to work this way, dot, and that's going to be my final m prime here. All right, so here we go. So let's do that with 1, 2. Well, when we go over the y-axis, we change the x and keep the y, and then we switch them. Let's do u. So u is 1, 5. So I am going to change the x, then keep the y, and then switch them. And that's going to be my u prime. And then we are going to do L, which is 8, 5. So I'm going to change my x, keep the y, and then I'm going to switch them. And that's going to give me my L prime. And then finally, I'm going to take my E, which is 8, 2. I am going to change my x and keep the y, and then I'm going to switch them, and that is going to give me my E prime. And now I'm going to graph my MULE prime on the xy axis. So we have m prime 2, negative 1. We have 5, negative 1. We have 5, negative 8. And we have 2, negative 8. This was my M prime, my U prime, my L prime, and my E prime. I'm going to connect them. M, U, L, E. And there you have it. That is the composition of MULE into M prime, U prime, L prime, E prime. However, there was another question that I erased, and it's a very, very important question. The question said, well, here you had a series of rigid motions, or you had a composition. Is there a single transformation that would have done the same thing? And the answer to that question is yes. Can you figure out what that would be? If you look at all of the original points, 1, 2, 1, 5, 8, 5, and 8, 2, and you look at your primes, you might notice that one of the formulas that we learned actually took place in one shot. But I'm going to give you a little hint here by showing you something that occurred here. If you go from point M to the origin, and then to my M prime, you might notice a particular angle formed, and that is a 90-degree angle. However, you might also remember that rotations naturally go counterclockwise, right? They go in this direction here. So there's really two ways that we could say what occurred here. We could say in one transformation, this was actually a rotation around the origin, negative 90 degrees, right? If we wanted to go clockwise, that would put that right on it. Or we could say there was a single rotation around the origin of 270. These are both the same, because you could see from MULE to our primes, what really occurred was the y went into the front and the x came to the back and changed signs, which is that formula. Tricky question. That's a Regents level question for sure. Okay, let's take a look at number 5. I'm just going to do 2 more here. Number 5 is also very much like a Regents question. Here they show you BUG and they show you B prime, U prime, G prime. And they want you to describe a series of transformations that was used to carry BUG onto B prime, U prime, G prime. So I'm just going to show you visually how I like to look at this, and then we're just going to write it out here. Okay, so I'm going to highlight B, U, G. And one thing I like to do when I'm trying to figure out a series of transformations, there are several different answers to this question, and they all would be acceptable on a regions. But one thing I like to do, I think the easiest thing for me to visualize is I like to find one pair of corresponding points. Well, obviously we have the G and the G prime. And what I do is I'm going to clone this here. I take that G and I just drag it right to the other one. And that right there would be a translation, right? So I start off by saying, well, I'm going to take triangle B, U, G, and I'm going to translate it. I always start that way. Well, what would be the translation? Well, to get from G onto G prime, I moved it 2 to the right and down 1, 2, 3. So 2 to the right would be 2, and down 3 would be a -3. So that's the first thing I did. Well, now you could see that if I were to write these in, my B is kind of over here and my U is over here. I got to get those on there. Well, one thing that I noticed that I can do, that if I can notice that the angle that B, G prime, and G, B prime is making happens to be a 90-degree angle. So I know now if I rotate BUG 90 degrees, if I rotate, I'll show you visually first. If I actually could take this, I'm going to clone that one now, and if I rotate it 90 degrees, right, around G, I have it right there, right? So I'm going to do that. I'm going to take my triangle, and now I'm going to rotate it. What point did I rotate it around? G prime. So I rotate it around G prime. How many degrees? 90. And now the last one is kind of simple, because now I'm just going to flip it over and it's going to be right on top of the other one. I'm just going to take this, I'm going to clone that, and I'm just going to say, well, let's just flip that, flip it left, right. No, that's not what I wanted to do. And then, yeah, I can do it like that. And then it's going to end up right there, right? Right on top. And that right there is clearly a reflection over the y-axis. Now, this is a very, very, very technical, official way to write what we just did. However, what would be acceptable in a question like this on our regions would just be a translation followed by a rotation followed by a reflection. However, my philosophy is always be as specific as you possibly can. And if you could do this, you're doing so much more than they're asking. And that's the perfect way to answer that question. Okay, let's just see if there's anything else that I could just help you with. I want you to do some of this on your own, but I'm just going to take number 7 and translate this question into a composition. They're asking you to take a point 4, 3, and they want you to move it on a translation of -8, 4. And then they want you to reflect it over the x-axis. And then they want you to rotate that 90 degrees. I mean, so that's how you need to start looking at these compositions. Glide reflections, if you see that, we haven't spoken about that yet, so you can kind of hold off on that particular question. Let's just look at the last one, and then we'll call it a day. Which composition of transformation will map ABC onto A prime, B prime, C prime? One thing that's important to be mindful of is which triangle is being transformed and which one is being stationary. So it's very specific. It's saying which composition will map ABC onto A prime, B prime, C prime. So it's triangle ABC which is doing the transformation. And when I just look at the graph, I see that triangle ABC is much larger than triangle A prime, B prime, C prime. So I know that at some place in this composition, they want me to choose which one is going to do what is going to take that triangle and put it on top of the other one. I know that it has to be one that makes this triangle smaller. Well, the only thing that makes a triangle bigger or smaller are going to be dilations. And the only one that's going to make it smaller is going to be a scale factor of less than 1 and greater than 0. Well, I see number 2 has a scale factor of 2, so I'm going to eliminate that. And I see that number 4 also has a scale factor of 2 in the dilation, so I'm going to eliminate that one. So right away, I know it has to be 1 or 3. So what I'm going to do here is I'm just going to take 1 point, an A. I'm going to look at my A here. The A point is 0, -4. And the A prime point, which it has to be mapped onto, is 4, 3. So I'm just going to put that point, 0, -4, through number 1 here and see what happens. So I'm just going to do number 1 right here. So I'm going to just have 1, 2, and then 3. And I'm going to see if I put 0, -4 through that, if it ends up being 4, 3. But then I'm going to try the other one, make sure it doesn't do it to both. So here we go. So I'm going to start this with point A. Well, point A is 0, -4. So I'm going to do a T23. So it's going to be 0 plus 2, which is 2. And it's going to be -4 plus 3, which is -1. And now they want the dilation. Well, the dilation is going to cut all of these in half, which means half of 2 is 1. And half of -1 is -0.5, say. And then we're going to rotate that 90 degrees, which is -y x. So my y comes to the front and becomes positive, which is 0.5, and the 1 goes to the back and stays the same, which is 1. Well, this should be my A prime, and that is not my A prime, right? This one right here should be the same as my A prime, which is 4, 3. So I am going to now do exactly what I did again with number 3. So let's see that. So I'm going to take my number 3 and do it down here. Okay, so I'm going to do it again. I'm going to do something. My A, there's the second part, and this point right here, after that, should end up being 4, 3. If it does, I know I am right. So here we go. So 0, -4. 0, -4, the first thing they're asking in number 3 to do is, starting up here, right, is to do the dilation, so to cut those each in half. Well, half of 0 is 0, and half of -4 is -2. Now they want me to rotate that 90 degrees, which is -yx, so the y comes in the front, becomes positive, and the x just goes to the back. And then they want to do the translation of a 2, 3. So 2 plus 2 is 4, and 0 plus 3 is 3. And sure enough, this point is this point. So we found our answer, which is number 3. Okay, so I am going to end that there. I hope that this was somewhat useful to you. I'll make another one before our first exam that's a little bit more comprehensive and sticks to some of the basics. But yeah, today was a difficult day, and these were not simple problems. So I hope this was helpful.